Hey everybody. Lots of questions about question number 6 on the homework. So I figured I would do a quick little walkthrough on this one, just so you see if you can get how to do this one. It's a little bit of a tricky one, and don't freak out about it. On the quiz tomorrow, I'm not giving you, or Friday, I'm not going to give you a question like this one. I'll give you a real straightforward, kick a football from the ground kind of problem. So in this one, you've got a rock or something on a cliff. What is it? A rock's being thrown from the top of a 50-meter high cliff. So there's my 50 meters right there. It's being thrown at a speed of 7 meters per second at an angle of 53 degrees above horizontal. And the question asks you for what its final velocity is when it hits the ground, which is a little bit of a different style of question that's on this one. So I've already done my components part right here, just so you can kind of see what that is. Every time you do one of these problems where it's launched at an angle, you might as well just do that as your first step. You know you're going to need to do your x and your y components no matter what. So VIX 4.2 meters per second, VIY is 5.6. So in other words, it's going up at 5.6 meters per second. It's going across at 4.2 meters per second. Because this is still doing projectile motion, we know that VIX equals VFX. It's not doing anything funky horizontally. We still know that this is going to be 4.2 meters per second all the way around. So what I've got over here in my top corner here is my little thing where I'm trying to figure out what my final velocity is going to be. So I'll remind you something real simple about this. It's easy to forget here, is that what we are literally trying to do is figure out the difference in terms of these components. This is VFX. This is VFY. In order to find out what our final velocity is, we need to know the final y component and the final x component. Well, the nice thing is the x component is exactly the same. It's still 4.2 meters per second. Again, it's constant velocity left to right, so we don't have to worry about that. The question becomes, what's VFY? So we've got VIY. VIY equals 5.6 meters per second, and that's up. So don't forget that that's a positive. We know acceleration. Acceleration is going to be negative 9.8 meters per second. We also know something about its vertical travel, which is dy. We know that it's vertical travel, and this is just delta d. And this is the weirdest thing about this one. This is the one that people miss. Its change in elevation is literally just 50 meters. In fact, it's negative 50 meters. It's falling. It doesn't matter that it's going up first. It starts at 50, it ends at 0. No matter how it makes that path, whether it starts at 50, goes up to 100, and ends at 0, it's still, change in displacement is still 50 meters, and it's still 50 meters negative. So if you want to do something like, you can enter your numbers this way. DI equals 50, and then DF equals 0 meters, as in it's on the ground. That's the other way to think about it. Both of these work. And then what we're trying to find is VFY in order to use our final triangle. So at this point, hopefully you can kind of see where we're going with this one. You need to find a kinematics equation, kind of figure out what you got, and try to figure out if you can find an equation that would have VF in it. And again, I take a look at this, I don't see any time, so there's only one equation when you ain't got time for that. VF squared equals VI squared plus 2A delta D. We don't need time for this one, actually, so that's kind of nice. And if you're doing this one, you can figure out, you're solving for VF squared, because that's what I want to find. VI squared was 5.6 meters per second squared, plus 2 times negative 9.81 times delta D, which is now negative 50. It's falling 50 meters. So what do we have here? 5.6 squared is 31.36. 2 times 9.81 times 50 ends up being plus 981. This is negative, so it becomes positive. Plus 31.36, just doing the algebra on there, is VF squared equals basically 1012 and change So that's VF squared. And then we take the square root of our answer. And I get VF equals 31.8 roughly meters per second. And now what's going to be a little bit weird about this is I'm going to put a unit on here. So I'll remind you when you take the square root of something that there's two roots to this. This is actually the VF here is going to be plus or minus 31.8 because it could be either one of those two numbers squared. If you take a look at the direction in our problem here, we know that VFY is going to be down. It's going downwards this direction. So I know that the VF is actually negative 31.8. It's going down. This makes sense actually that it's going a lot faster. It went up, at what, 5.6 meters per second. So it shot up just a little bit and then it fell a long ways. So it makes sense, A, that the speed here is negative, and B, that the speed here is quite a bit faster since it was going, it was going downhill. It had a lot of time to accelerate off that cliff. So negative 31.8. So now we know a couple of things about our kind of final triangle here. Let me move this out of the way and get a little bit of an eraser going here. Let's see, eraser time, if I can get it to wake up. Using too much processor. There we go. Eraser, come on. Give me my eraser. Come on. The computer is definitely a little bogged down with all the things I've been doing on it today. Okay, good enough. So now if I look back at my little triangle here, I know a couple of things about this. I know that VFY is negative 31.8, or basically negative 32. That's VFY. I know VFX is 4.2, and then I'm trying to find VF. So this is a Pythagorean theorem problem in terms of trying to figure out what this is. So 31.8 squared plus 4 squared is a squared plus b squared equals vf squared. So I get vf squared is 1027. And if I take the square root of that, so 31.8 squared plus 4.2 squared equals vf squared. And then I take my square root of that. VF here ends up being approximately 32.05. And this makes sense as well, since most of our speed here is indeed vertical component. Most of our speed here is vertical. Very little of it's horizontal. It's not going very horizontal off the cliff. It's mostly going vertically down the cliff after it's falling this huge distance. So VF is about 32 meters per second. Sorry, and it should be negative, but it's at an angle. And so then the last part you would do would be to figure out the angle. Tangent of theta is opposite over adjacent. So in this case, tangent of theta is 4.2 over 31.8. This has got to be like a nearly vertical angle. Inverse tangent of 4.2 divided by 31.8 is like 7 degrees up here. Basically 7 degrees. 7 degrees from vertical, or basically 83 degrees, something like that, if you want to think of it that way. Almost straight down, it's 7 degrees away from vertical, or 83 degrees from horizontal, whatever you want to do from that, basically vertical. So there you go. That's the quick walkthrough on problem number 6. Don't need to worry about the maximum height. It's just kind of figuring out that if you want the final velocity, you're finding the x and the y components of your final velocity. So there you go. Sorry, I just covered up my face and all that. Hopefully that helped a little bit. Again, on the quiz tomorrow, not giving you anything this hard, so don't stress about it. Have a good night.